Hi, this instructional video is about parabola. Yeah, it's like the parabola you learned in Algebra 1, the quadratic functions. But there's just a little twist to this one. For example, this almost looks like a quadratic function. Well, actually it is. But we're going to take a different route in graphing this one. Now look at the direction. It says graph the equation. Identify the focus and the directrix. Now there's a couple of new words we haven't heard before. So let me quickly brief you on that one. You see, in Algebra 1, when we talked about quadratic functions written in standard form, y is equal to ax squared, let's say, without the b or the c term. So there is no shifting, and there is no y-intercept other than a 0. So we know it's going to be a parabola, and given that the a is positive, it's going to open up. And so we know it's going to be a standard parabola that goes through the origin 0 and 0. And it turns out there is a certain property in a parabola when you choose any point on the axis of symmetry, let's say randomly over here, then that is called the focus. And the focus has an equal distance to a given directrix, given the opposite value of the y. So this line is called the directrix, and that point on the axis of symmetry anywhere inside a parabola is called the focus. And the distance from that focus to the curvilinear line of the parabola is equal to that line to the directrix, given to the opposite side of the focus. So given this function, x squared is equal to negative 6y, we could determine what the focus will be and the directrix will be. And we could estimate the graph, and this is always assuming our discussion will always evolve around the fact that the vertex is at the point 0, 0. So given that, here's how this works. We're going to use a thing called a standard form. And the standard form is given as x squared is equal to 4py. So since here we are given the equation x squared is equal to negative 6y, we're going to substitute negative 6y into that x squared because that's what it says it is. X squared is equal to negative 6y. So we're going to put it in there into that standard form. So what we end up is negative 6y is equal to 4py. We're going to solve for p because we're going to combine the y's and the coefficients together. So divide the 4y to both sides of the equation. And when we do, the 4p's or 4y's, they simplify, leaving you with a p. And on the left side, the y's cancel out, shall we say, and negative 6 over 4 reduces to negative 3 over 2. So that is the focus, and the coordinate of that focus is actually 0. When x is 0, the y, the focus point on the y-axis is negative 3 over 2. That's the focus. And the reflection of that is where the directrix is on the y. So the y, the directrix, is 3 over 2. So if we were to graph that, let me do a little miniature version over here. The focus is at 1, 2, negative 2. So the focus is right there in between, negative 1 and 1/2. And we know it has to open downward. And then we just said the equal distance apart from here and randomly to there to the directrix. So what is that point? What is that line? The horizontal line is when the y is equal to 3 over 2. And there's your graph. That's the x-axis, okay? There's my graph, there's my focus, there's my directrix. Why don't you try number 2 now? Okay, so you said, this is very similar to what you showed us number 1. So let's use the standard form, x squared is equal to 4py. And since x squared is given as 16y, that's what you substitute in there. So you end up with 16y is equal to 4py. So when you solve for p in this case by dividing 4y to both sides of the equation, the p is equal to what's on the left side, 4. And that's going to be your focus. So it turns out when you have a y on the right side and an x squared, you actually get a vertical axis of symmetry. And so this is going to be given as a coordinate when the x is 0, y is positive 4. And this time, we know it's going to open upward. So 1, 2, 3, 4, that's the focus. And so it's going to open upward, going to the vertex 0 and 0. And the equal distance away is, of course, 1, 2, 3, 4 when y is equal to negative 4. And that's my directrix. There you have it. Yeah, that's a brick. You know, from like the song from the Commodores. She's a brick house. Oh, yeah. Anyway, yeah. Oh, Jesus. That was a brick. So now, instead of an x square, what do you know? We have a y square. To graph this one, we're going to use a standard form set for the horizontal axis of symmetry. Yeah, and that's given as y squared is equal to, guess what? Not 4py, 4px. Remember we talked about the inverse functions, where the y's and the x, the domain and the range switch places? Yep, this is the one. And so since in this case, the y squared is given as 24x, so that's what we substitute in here. So we end up with 24x is equal to 4px. We're going to solve for p this time, which will be the focus, but this is not going to open up or down like here. It's going to open either left or right. To solve for p, we're going to divide both sides by 4x. So that the 4 and the x, 4x simplify, leaving you with the p. X is reduced, 4 goes into 24, 6 times. Now be careful. Last time when x is 0, the focus y was negative 3 over 2. This time, since it's opening, guess what this time? It's going to open right. Because 1, 2, 3, 4, 5, 6. Here's the focus. The parabola is going to go through the origin. So to accompany that focus, which is inside the parabola, it has to open right. That means directrix will be on the left side, the opposite side. 1, 2, 3, 4, 5, 6. Y is equal to negative 6. I'm sorry, not y. X is equal to negative 6. And x is equal to 6, and the y is 0. So there's the focus, and there's the directrix. Now why don't you try this one? Good. You see, it looks very complicated, but when you recognize the pattern, it's not too bad. The standard form to find the horizontal axis of symmetry is, of course, y squared is equal to 4px. So now you take that y squared equals negative 14x, substitute into the y squared here, you end up with negative 14x is equal to 4px. We're going to solve for p to find the focus by dividing both sides by 4x. Therefore, 4x is simplify. P is equal to now, well, 4 does not go into 14 evenly, so we're going to end up with a fraction. Common factor of 2, so 7 over 2. To get a visual, we could say that's going to be negative 3.5, I guess, huh? So now, that's our focus. This time, we have an x that's going to be negative 7 over 2, or 3.5. 1, 2, 3, 4. So focus is right there. And to accompany that, we have to have a parabola that opens leftward this time. And the directrix, which is equal distance away from the arc of the parabola, is going to be at 1, 2, 3, 4, positive 3.5. So the x, the directrix, will be at positive 7 over 2, and the focus is going to be at negative 7 over 2, and y is 0. There you have it.